Hello folks, we are back with the part 9 video and the 17th problem. The question says that it is 1 by 3 into 5 plus 1 by 5 into 7 plus 1 by 7 into 9 and so on. 1 by 2n plus 1 into 2n plus 3 is equal to n by 3 times 2n plus 3. We need to show that. So as usual, we'll take let Pn represent the given mathematical statement. Step 1 to show that P of 1 is true. We know how to do step 1. It is 1 by 3 into 5 to be equal to 1 by 3 times 2 into 1 plus 3. Let us check what it is. Consider the left hand side. It is 1 by 3 into 5, which is 1 by 15. And RHS is 1 by 3 into, let's see what's there in the bracket, 2 plus 1, 5. Again, that is 1 by 15. That is how LHS becomes equal to RHS, and therefore P of 1 is true. Step 2 is assume P of k is true. Wherever n is coming, there we're going to substitute k, and that's how it's going to come. 1 by 3 into 5 plus 1 by 5 into 7 plus 1 by 7 into 9 and so on. 1 by 2n plus 1, sorry, 2k plus 1 by 2k plus 3 is equal to k by 3 times 2k plus 3. So that's how it is. Then you have to show that P of k plus 1 is true. So now we are, as we said in the previous question, we will be using our observation and most of the terms we'll be considering constructing like that. So let's see how we can use our observation to construct this. This is the kth term. Let's see what's the k plus 1th term. Look over here. 3 into 5. So 5 comes here. And between these two, there's a difference of 2. That's enough. So if you know that this is ending in 2k plus 3, this will start with 2k plus 3. There's a difference of 2, so it will come to 2k plus 5. Because we are taking the kth term, there was k here. Here we are taking k plus 1 term, so k plus 1. 3 is as usual, and this last term is what is coming here. So the last term will come here. So that's how we are predicting this. And then to prove this right away, we will start with the LHS. In the LHS, we have 1 by 3 into 5, 5 into 7, so on, 1 by 2k plus 1 into 2k plus 3, 1 by 2k plus 3 into 2k plus 5. So this much we are able to substitute because we know P of k, and that is coming to k by 3 times 2k plus 3. And the last term is 1 by 2k plus 3 into 2k plus 5. As usual, always there will be some common term. So let's take it out. 1 by 2k plus 3 is common. First term we are left with k plus 3, and next term you are left with 1 by 2k plus 5. Here we are going to equalize the terms, the denominators. So both numerator and denominator is going to be multiplied by 2k plus 5 here, and both numerator and denominator will be multiplied by 3 here. So what is going to happen? It is 1 by 2k plus 3. When we multiply, it is 2k squared plus 5k. When we multiply, this is 3, and denominator is 3 times 2k plus 5. If you're very observant, 3 and 2k plus 5 has come, which means that this 2k plus 3 is somewhere getting cancelled. Let's look at the simplification of 2k squared plus 5k plus 3, because you know that 3 into 2 is 6. Probably you could write it as 2k squared plus 2k plus 3k plus 3. Like that, 2k could be taken common, you will get k plus 1. 3 could be taken common, k plus 1. So this finally breaks us 2k plus 3 into k plus 1. That we can bring here. 1 by 3 into 2k plus 3 into 2k plus 5 is there here. And here in the numerator, you have got 2k plus 3 into k plus 1. What happens? The 2k plus 3, 2k plus 3, they will cancel each other, and you are left with k plus 1 by 3 into 2k plus 5, which is the RHS. So you have LHS is equal to RHS, and that's how P of k plus 1 is true. So from steps 1 and 2 by principle of mathematical induction, we are done. That is our problem number 17. Then this is the last problem of equality. In the exercise, henceforth, we will take 2 problems on inequality and the remaining problems on showing that's a multiple of a number. So the next problem that we're going to take up, it is going to be a problem of inequality. The format is the same, but steps here and there will vary a little. So let's see now how to go about doing it, and let's take the next problem, problem number 18. think we will restructure this because we may have some steps may change and it won't be so tailor-made like before. Yeah, so let's see what does the question say. 1 plus 2 plus 3 and so on n. So it is like we were taking now the 18th problem is less than 1 by 8th time 2n plus 1 the whole squared. See, sometimes what happens is in the NCERT textbook, I beg to differ, but I feel that problems could be a little more graded. If it was a little more graded, the person who's learning for the first time, that person would feel comfortable. For example, we have one inequality problem here, and then we have Law's problem as inequality. But if it could be clubbed together, then the child learns all equality problem first, then he learns the inequality problem, then he learns the multiple problems. So for an average learner, first time learning becomes much more easier. I feel that way. Of course, each person has a different view. So there's one more inequality problem that's coming last. This is the only inequality problem that will do now. Then we will take it up at the last. So let's have it. Once again, let's check it's 1 plus 2 plus 3 and so on till n and less than 2n. 1 by 8 times 2n plus 1 the whole square. This is how the problem is. Let Pn represent the given mathematical statement. To show that P of 1 is true, same way. First term from here is less than 1 by 8 times 2 into 1 plus 1 the whole squared. So LHS is 1 and what is RHS? 1 by 8, 2 plus 1, 3, 3 squared 9, 9 by 8, I don't know whether it is 1.125, yeah, I think so, like 9 and 8, 1s are 8, 1 remaining, decimal point 0, 1s are 8, 2 remaining, because of the decimal point 0, 2 times 16, 4 remaining, decimal point, yeah, 1.125. Isn't LHS less than RHS? Yes. So here LHS is less than RHS. Therefore P of 1 is true. We are done. Then assume P of k is true. Means what? 1 plus 2 plus 3 and so on till k is less than 1 by 8 times 2k plus 1 the whole square. This is true. To show that or to prove that P of k plus 1 is true. So what do you have to show? So in essence, you have got to show 1 plus 2 and so on k plus 1 is less than 1 by 8 times 2k. See, my common sense says that it should be 2k plus 3. But let's check if it's correct or not. Because k is replaced by k plus 1. So it is 2k plus 2 plus 1. Yes, it is 2k plus 3 the whole square. You've got to show this. So here also let's start with the LHS. Consider the LHS. And what does that say? It is 1 plus 2 and so on till k and k plus 1. As usual, till the k values we're going to substitute. Only thing that equality will go to inequality because k is less than 1 by 8 times 2k plus 1 the whole square plus k plus 1. Okay, so we can have it equalized. Let this also have the 8 so that we can work comfortably. 2k plus 1 whole squared 8 times k plus 1 by 8. So 1 by 8 outside, opening the bracket 2k squared, sorry 4k squared plus 4k plus 1 plus 8k plus 8. So how much does it come to? 4k squared plus 12k plus 9, right? So how do we go for the factorization of this? 4k squared plus 12k plus 9, 9 4s are 36. And 36, what all factors? 6 6 are and all that. You can have 6 6 are, then you can have 9 4s are and all that. I think 9 plus 4 will not. I think 6 6 are. So plus 9. So you can have a 2k common. 2k plus 3. And same way here. 2k plus 3 with the 2 common. And 2k plus 3. So it is coming to 1 minute. did I, oh 3 common, sorry 3 common, otherwise I could have it directly also, yeah 3 common, 2k plus 3, fine. So it's 2k plus 3, 2k plus 3 the whole square, and that's exactly the RHS, but this is the RHS. So what do we have? We have LHS worked out to be less than RHS, and that is how PK plus 1 is true. So from steps 1 and 2, given mathematical statement is true by principle of mathematical induction. That's our first inequality problem. The remaining we will be taking it up in the next part. Thank you.